Hello everyone, let us create a simple linear regression equation using this sample data. This sample data shows the relation between the number of hours a student studies against the exam scores. So this is a sample data collected. Actually, this is a fictitious data, but it helps us to show us how to get the simple linear regression equation out of this, the best fit equation. So there is a trend, the more hours you study, the more you are going to score. This is just a common sense. So with this data, usually you start from the data and you plot the data as a scatter plot. Like, for example, you will have the hours studied on the x-axis and the score on the y-axis. And then taking the data given here, you will plot this data. For example, when 1 hour is studied, the score is 50. When 2 hours is studied, the score is somewhere here, 55, a little higher than that. So you will have to plot all of this data for the different pointers, and when you finish plotting all of the pointers, you get scatter plot like this. So this scatter plot shows you a trend. So you can get the best fit equation by different methods, but the method I am going to show you today is just like visually plotting a straight line that passes close to as many of the points as possible. And this line, once you plot it, it is like linear equation, and the linear equation, as you know, it is represented by this y equal to mx plus b. So you know the y-intercept here, you can estimate the slope of this line, and then if you get these 2 pointers, you have the slope and the y-intercept. That means you have determined the best fit equation. So that is a good example of how best fitting models are done. So once you have this line, you can then determine, for example, if a student tells you that he studied like maybe 7 hours, then from this you can determine what the score is going to be. Like, you have developed a model. The model is not 100% accurate. It has errors involved with it. But in any case, this is a good example that shows you how you understand the concept of simple linear regression, and also you can relate it to the algebra you have been learning at school. And now all of the points that we have seen previously are now plotted like this. Your task now is to pass a line. You have to be very careful to pass a line. As I said, there are statistical methods by which you can obtain the equation of the line, but today we are just doing by judgment, visually passing a line that passes through these pointers. And one of the things we can do is like we have a ruler. Now after you draw the line, the best fit line, this may not be exactly the best fitting line. It may be a little bit variable from this, but the important thing is to get the logic. So it means you get your y-intercept, which is close to 45 something, the value. And the slope, we can get an idea of the slope from one point here between 70 and 80. So this point is like 9 and 90, and this point is 6 and I think around 75. So we can determine the slope from this. So 90 minus 75 divided by 9 minus 6, which is 15 over 3, which is close to 5. So that means you have determined the slope and the y-intercept b. That means the equation for this line could be represented as y is equal to mx plus b, which is 5x plus 45. This is an approximate equation that you have developed by passing a line. You can do this by trial and error, create another line, maybe which is closer to the pointers, as close to the pointers as possible. But there is a strict, precise statistical method which you can use also. That one will give you precisely what the equation of this line is. And actually I have such a result which I would like to share with you. It is this one. If you look at it, this is the best fit line which the software has developed, plotted it, and then gave us, y is equal to 47.27 plus 4.85x. So our equation that we, by our own estimate, the one we found was y is equal to mx plus b, and we call this like 5x plus 45. Yeah, we are close. This one gives us y is equal to 4.85x plus 47.27. Because this is done by the software, it is more precise, but ours also is close. But the most important thing here is how data is related to algebra. The algebra that we did here to find the slope and the y-intercept and to get the equation of the best fit line, it comes from the data. Sample data was collected on a student's score against the amount of hours they studied, and that sample data we collected on only for 10 students. But if we did for hundreds of students, thousands of students, we'll get a more reliable information. So you see, most of the things done nowadays, it is based on data and mathematics. Mathematics and data will take you a long way because course, like this kind of things in a sophisticated level, a lot of things will be done, but the basic remains to be the same. You are trying to model a real life by mathematical techniques like this. This is one of the simplest models. It's called simple linear regression. Thank you for your attention. Have a good one.